Okay, so let's talk finally about the particular research gap or goal that you're going to work on. Your gap, your goal has to combine the societal elements, the human practices, the design elements in the wet lab, and also the theoretical foundation, which is usually one of the things that dry lab works with. Now, again, in science, we tend to talk about research gaps, things that are not done. Nothing has ever been done about this. And then we have to say, why should it be done? In engineering, it's more common to talk about the aim or goal of the research, because there are a lot of people working on something currently, but there are still limitations. And it's not a matter of whether it should be done. Everybody agrees it should be done, but how is the best way to do that? Now, of course, this is not an absolute distinction. There's a lot of overlap between those, but it's a good general distinction to start with. So a research gap says, as to the best of our knowledge, nothing has ever been done on this topic. And so we have to justify, so why should it be done? There's a lot of different research that could be done. Why this? We know something, but there are a lot of different gaps. Which one of those gaps should we fill? So I think this is probably more important in, again, social science and science than it is in engineering. So how does that relate to your work?
In social sciences, for example, in language teaching, there have been so many studies on how to teach English, how to teach Chinese. What's new? So you have to say, I have a new group of people, or a different age group, different societies, different methods, whatever is new, then that's your research gap. So we actually concern both gap and goal. What's the purpose of doing this research and what's new? And for master's students, as long as you can finish a study independently to show that you know how to conduct a study from the beginning to the end, that's enough. But for a PhD student, you also have to show how you improve on the theoretical model. That's the difference for a PhD versus a master's level.
So to use an illustration, if you're building a stone wall, a master's student is putting the little stones in that make it a little bit more stable, whereas a PhD student is adding another rock, another level to that stone wall. So then again, in terms of goal, with the engineering perspective, we often talk about this has been done. Nevertheless, however, there are still problems, there are still limitations. And so we justify not why it should be done, but why what was done before is still not good enough. And it's often, again, a small research area, a lot of people working on it, and we have to show that there's a limit to the previous work and that we can do better. So this aspect of it tends to be more common in engineering. No matter which one we're talking about, you have to know what has been done. You have to read previous research articles, particularly the most recent work. A good example of this was the 2022 team that talked about PAC omega. And they knew that fatty acids, omega fatty acids, such as DHA and EPA, which are components of fish oil, are useful for preventing or reducing cardiovascular disease. And so they decided, okay, we'll make DHA. I don't know why they chose DHA, but that's where they began. And then in March of 2022, just 6 months before the competition, they found articles that showed that EPA reduces cardiovascular disease, but DHA actually inhibits that effect. It has a negative effect. And so they had to switch at that point to make EPA. They had to change the whole focus of their research. When they decided to do the work, there were articles available that were pointing in this direction. but somehow they miss those. So it's important to do a very comprehensive search, and as particularly of the most recent literature. We'll talk more about how to get at that literature in the next unit. Another thing that's important is the quality of the work, the quality of the journals that this work comes from. And that again is something that you have experience with.
Yes, for many novice researchers who have no experience, they usually tend to find some works from predatory journals. We may talk about predatory journals later. Or they find some articles, when I look at it, oh my God, the English is horrible, the data is messy, the interpretation don't make sense. So in other words, novice researchers need to consult with expert researchers to find out what's the most useful journals in your field. And then what's the most consulted journals we have been using. So all these, that's why we need to go to schools. We need to attend different classes so that we can get information from the expert so that we won't spend a lot of time finding trash.
And again, this is why it's important not just to choose something that you're interested in, but something that someone in the department, in the school has experience with, so they can direct you to the best material, the latest material. It will be much easier for you in the long run. So there are a number of different things that need to be considered in terms of doing research. One of the ideas that we run up against is precision versus accuracy. Precision has to do with how close your data is, how consistent your data is. Whereas accuracy has to do with, is it on target? Is it correct based on the natural paradigm, natural circumstances? So obviously we have to aim for being correct. We have to aim for accuracy. But precision is something different. Sometimes people will hit a very small area, but it wasn't their original aim. All of their data, all of their information is very consistent, but it's not their original target. So the easiest thing to do, and this is very common in research, is to move the target, where you actually change your research goal as you go along. You start in a certain direction, and then you modify. Do you have any examples of that?
Exactly. This is something novice researchers don't understand. They start with 3 research questions. When they start to collect data and find some results, they realize they're not at this target. It's all gathering over there. So what should they do? I tell them, change your research questions. They feel, I'm already committed to my research questions. Am I lying to my audience by changing my research questions? No, you have to be flexible.
Right, so again, by changing your questions, you can make your results both consistent and accurate. The questions and the results match, and that's what's important.
Because sometimes you may have asked the wrong question. By investigating in the process, you find, actually all the data, all the results are here, but I was looking over there. That's why I need to change my question to address the issues right here.
Okay, a second idea that's important is this idea of false positive versus false negative. Now again, to give an example from COVID, which people are more familiar with now, a false positive in COVID would mean that the test says you are positive, you have COVID, when you really don't. That's a false positive. A false negative is that the test says you don't have it, you're negative, but you really do. Now, which of those is more dangerous? Well, if it's a false positive, you're afraid, I've got COVID, when you really don't. But if it's a false negative and it says you don't have COVID, and you just say, okay, I'll just go out and do things with my friends, then many other people get COVID because of that false negative. So in this case, the false negative is what they're trying to avoid in the tests. And that's why the rapid tests sometimes indicate a positive test when you really don't have it. But in other situations, one or the other might be more important. One of the things that you see this in is these test kits. Again, most of the test kits that are available, as you're familiar with COVID, they have a control line that shows that the test is actually working, and a test line that shows whether you have the disease or not, or whatever they're testing for. And it's important to remember that the default, what's there, is negative. It doesn't show anything. So what should show up? Do you want a positive test to show up or a negative test to show up? Well, let's use an example with color. If I put two color bars on the screen, 100% black and 85% black, and you look at those, one may be a little bit lighter, but it's kind of hard to tell. But if I put up a 15% difference between 0 and 15, then you can see the difference very clearly. And so most tests try to have whatever you're testing for show a line, because any line, no matter how faint, is a positive test, and it's much easier to test that than a reduction of some value.
This example actually reminds me of statistical significance. Sometimes in social sciences, we also test for whether there is a difference. Of course, the default is there's no difference, but we want to see if the two groups demonstrate different reactions. Then sometimes we also have false positive. So what should we do? Before we feel, oh my God, it's positive, then I have to check whether my sample is big enough and whether this test tool, the statistical tool, is the right tool to use. So in social sciences, many times we prefer triangulation. In other words, we don't depend on one tool, one result, but we collect other evidence to triangulate to see if all of these different sources point to the same thing.
And the same thing again with science. Sometimes you have a rapid test that gives some indication, and then you have something like the PCR test that's more accurate but more expensive, takes more time. But you get a quick idea first to see if it's even worth doing a more detailed test. So all of these are things, as you're developing your design, you're developing your experiment, you need to consider all of these from the very beginning. One final thing to look at is whether you're doing something completely new or improved. Again, this applies to different areas within the iGEM, but particularly to this idea of BioBricks, which is key to the concept of iGEM. BioBricks are built from existing DNA segments, and so all of them in some way are improved, modified. But you don't start building something from scratch. You check the list of existing BioBricks to see if anyone has done something similar before you just start building something and then find it's already been done. And so similarly, in your choice of a project to begin with, you don't always have to pick a brand new project every year. In fact, your professors have an ongoing research in some area. And the judging standards for iGEM actually encourage you to do something or improve on something that has already been done. Improvement of existing BioBricks is one of the criteria for a gold medal. And it can be not just the BioBricks, but the whole idea, the concept from a previous team. They got this far and we want to take it one step further. You don't always have to begin over again. In research, many of your students probably work on similar topics because it's something that you have experience with. That's true of all researchers. They tend to work on the same thing and keep making it better and better. You can get farther in 1 year if you have a more solid foundation. So it actually saves time.
But be that as it may, when it comes to international competition, the criterion usually is on what's new. So when we want to look at all those different dissertations, what stands out as the medal dissertation? It's usually a new paradigm, something totally new.
Okay, so again, it's a balance. It's easier in many ways to work on something in terms of marketability. You may get a marketable product sooner, but novelty also is important. And so as you're choosing a research topic, all of these things are important, and hopefully this will help you to move more quickly in a beneficial direction.